Have you ever wondered what really happens when a bowling ball races down the lane? Today we will see the simple engineering behind every roll, spin and crash. First, pick a ball. Then learn how you turn energy in your body into smashing power. Finally, watch how the pins fly. And why smart technique wins games. No PhD needed, this is for everyone. Let's put on our imaginary shoes and start. I'll keep the math small and the pictures big. We'll use 3 words a lot: potential energy, kinetic energy, and friction. Watch the ball closely. We will label each force as it appears. We'll even peel a ball apart to show how design matters, and we'll compare heavy and light balls to measure momentum. Ready? Let's pick the perfect ball and turn your swing into science. Follow the lane with me. Our lane is a lab today. Step 1. Select a ball that fits your body and your style. A good start: try a ball about 10% of your body weight. Find your ball, warm your wrist. Next, we turn potential into motion. Let's step through the swing and the lane. Simple, clear, visual. When you lift the ball, you store potential energy. That depends on mass and height. Potential energy is PE equals mgh. Simple and useful. More height or more mass means more stored energy for the throw. Fit the holes correctly. Good fit lets you apply spin and keep a smooth release. Too tight or too loose ruins the transfer of energy from your arm to the ball. A relaxed grip gives consistent spin and speed, the key to repeatable shots. Your swing is an energy store. The backswing raises the ball and stores more PE. Think of the arm like a pendulum. Smooth motion is efficient. Your step forward adds momentum. Release at the bottom of the swing for max speed. At release, the energy moves from you into the ball. This handover must be clean. A quick, low release gives the ball higher launch velocity. Release too early or too late wastes the energy you built up. Let's do a quick, friendly number. A 6 kilogram ball at 7 meters per second. KE equals 1/2 times mass times velocity squared. That works out to about 147 joules of kinetic energy. Double the speed increases energy 4 times. Heavier balls also raise energy, so you can add energy by going faster or by using more mass, within safe limits. But only if you can move the heavier ball smoothly. Otherwise you lose speed and energy. Now the ball leaves your hand and travels 60 feet. The lane changes the story. At first, the ball often skids on oil. That protects its speed until the back end. This slide preserves kinetic energy for the final destructive section of the lane. So far, choose mass, fit holes, load energy, release at the bottom. Now watch the lane zones. Next we'll zoom into friction, the secret that makes a hook work or fail. The front 2/3 of the lane are oiled. That reduces friction. Here the ball slides more than it rolls. It keeps speed for later. Low friction means little heat loss. Energy stays in the ball. Then the ball reaches the dry back end. Everything changes. Dry wood gives more grip. Friction spikes and the ball can roll or hook. The skid becomes roll. Rotational energy engages with the lane surface. When friction grabs a spinning ball, it curves toward the pocket. We call the change sliding, static friction. It makes the hook devastating. Friction tilts the rotation axis and the path changes quickly. All this saved energy hits the pins in a fraction of a second. At impact, we see an inelastic collision. Energy transfers into the pins. The ball's energy and momentum create a chain reaction. Pins knock pins. Quick story: team brute force versus team science. Same lane, different strategies. Brute force throws hard and straight. Lots of energy but less angle at the pocket. They get strikes sometimes, but also nasty splits. Team science studies oil patterns and uses a hook to hit the pocket at an angle. Sarah times her release to save speed, then let the back end grip and turn. Result: a controlled pocket hit and a cascading strike. Technique wins. Final frame, tied score. One smart shot decides the game. She breathes, times the release and sends the ball with a clean hook. Strike. Team science celebrates. Physics beats pure brawn today. Quick summary: lifting stores potential energy, the swing converts PE to KE, a proper release gives the ball velocity and spin, oil preserves KE, the dry back end creates grip and the hook, impact transfers energy into pins. Remember 3 takeaways: pick the heaviest ball you can control, release at the bottom, use lane friction smartly. Go try it, see the forces yourself. Thanks for watching.